Today's video is a new section. It's section 5.6. It's on inverse trig functions, and we're just going to be doing differentiation today. Your homework is 41 through 63. So what that means is your list of derivatives and integration of 31 is going to increase. We have 2, 4, 6 new ones today. Let's first review ever so slightly about inverses. This is the way we would write it. The inverse is sine of x equals theta. And again, my brain has a hard time thinking about it that way. What this really means is with inverses, you switch out your x and y's, right? And so what that means is the sine of what angle equals x, right? And so that's what I'm solving for what angle? That is the ratio. That is the ratio. And so that's the kind of notation, that -1, which meant inverse. That's the notation we used in Algebra 2 and in pre-calculus. But there's another way of writing that, and it all depends on just which book. And this is the way that the AP test writes it. Instead of writing this -1 to denote inverses, they write arc, A-R-C, in front of the word. That word arc means inverse. So arc sine of x is the same thing as this. So I don't really think in terms of inverses. I switch out my x's and y. This is how I think of it. Sine of maybe 30 degrees is 1/2. So arc sine of 1/2 equals 30 degrees. So let's go ahead and get our 6 new derivatives. Here, and so I'll be giving you a new handout tomorrow also to have an expanded list. So the derivative of some function y equals arc sine of x, again that just means, right, what does this mean? Y equals the inverse sine of x, that's what this is saying. That's my function. When I go and take the derivative, it's 1 over the square root of 1 minus, and whatever is here in this placeholder. Whatever is here, you put it in here and you square it. Again, if this was something like 3x, then this would be 3x in here, which would be 9x squared, and then you have to do the chain rule, times 3. The derivative of the 3x would be times 3. Now I'm kind of getting ahead of myself. Next one, the derivative of the trig function called arc cosine of x, which means the cosine inverse of x with respect to x, is the same thing except it's negative. So again, whatever is here, you put here and you square it. Tangent. So the derivative of the inverse of tangent, which we call here in this textbook and by the AP test arc tangent of x with respect to x, is equal to 1 over 1 plus x squared. So whatever is here goes here. So if this happens to be 1/2 x, it goes 1/2 x inside of here times 1/2, because you have to do the chain rule when you take your derivative. Next one, the derivative of the inverse of secant of x, in other words, arc secant of x with respect to x, it's 1 over the absolute value, the absolute value of x times the square root of x squared minus 1. Let me put the little dot for times. I did it again, huh, didn't I? The derivative of arc cosecant of x with respect to x is the negative of this. -1 of the absolute value of x times the square root of x squared minus 1. And last but not least is cotangent. The derivative of arc cotangent of x with respect to x is -1 over 1 plus x squared. So it's very similar to this one, right? So these two kind of go together, positive and negative. These two go together, positive and negative. And these two go together, positive and negative. Maybe a way of remembering them. There's only 3 to remember. And then knowing which ones are positive and which ones are negative. So let me proceed. And in all of the homework problems except for the last 2, you're going to literally just find the derivative. In the last 2, you're going to find the equation of the tangent line to the original function at a given point. So here's your original function. I'm going to do one of your homework problems, number 47. In fact, I'm going to do 2 today. G of x equals arc sine of 3x over x. So I'm going to go ahead and I'm going to take the derivative of this. How do you know that? Because I denoted over here. What am I going to use? The quotient rule. So it means I'm going to take the derivative of this, which is 1 over the square root of 1 minus, and then whatever is here, 3x quantity squared, times, now I got to do the chain rule. Now I have to do the derivative of this, times 3, times, I leave the denominator, minus, leave the numerator, times the derivative of the denominator, all over the denominator squared. So now what I wanted to do was to get rid of the parentheses here. So the 3 gets the square and the x gets the squared, so it's 3x, 3 times x, 3x in the numerator, square root of 1 minus 9x squared, minus arc sine of 3x, and I put the x squared underneath this numerator and the x squared underneath this denominator, and realized it's a complex fraction. I need to multiply by the reciprocal. And so I have this, and so I'm going to get a common denominator, multiply both sides by this. And in doing so, I'm just going to put it there in front and call it a day. Next. Number 57. 8 times arc sine of 1/4 x minus x times the square root of 16 minus x squared all over 2. Much more dynamic. First thing I did is I rewrote the second term so I could make it product rule for my derivative. Now I went ahead and I started taking my first derivative. So I left the 8 there. Arc sine of 1/4 x is still again 1 over the square root of 1 minus whatever that x is, which happens to be 1/4 x quantity squared, times, now the chain rule, the derivative of 1/4 x, it's 1/4. Sorry. This is not the chain rule. I'm sorry, product rule. Only this is. This is just one function. So I took the derivative. I put down the minus. I put down a square bracket. So now I'm going to do product rule here. I'm going to take the derivative of this, leave it alone, plus, leave it alone, take the derivative of this. Let's do that. The derivative of 1/2 x is 1/2, leave it alone. Plus, leave this alone, the derivative of this. Well, that square root is really to the 1/2 power. So I'm going to bring down my 1/2 times the 16 minus x squared. Now I got to decrease it by 1, negative 1/2. Times, now I have to go inside of here, chain rule, take the derivative, that's 0, that's bring down my 2, that'd be negative 2x. Close up my square bracket, because I have to eventually distribute the negative to this term and to this term. So this times this goes with this term, so that's 2, minus, and so now what is this going to be? That's just this over 2. This whole term happens to be negative. I brought the negative here. This is x times x, x squared. This 2 cancels with this 2, but I still have a 2 in the denominator, and this goes in the denominator. I went ahead with the 1/4 x quantity squared, so that would be x squared over 16. I unfortunately started to make a square bracket. I didn't mean to do that. I wanted to distribute the negative to both. As I did that, I went ahead and made a common denominator. They both have a common denominator, 16, so it's 16 minus x squared all over 16. I just copied. I didn't do anything here besides the distributing. Then I gave each of these its own square root, copied. This is now a 4. So here's 1, here's the other function. I went ahead and multiplied by the reciprocal, so the square root of 16 is 4, went up here in the numerator. That's now 8. 8 over the square root of 16 minus x squared minus this plus this. I didn't change anything. So here you can start seeing a common denominator. The two factors are 2 and the square root of 16 minus x squared. So this one needs a 2 over 2. This one needs the square root of 16 minus x squared, numerator and denominator. So in doing so this one got the 2, so it became a 16. This one here needs the square root of 16 minus x squared. When you multiply 2 of them, it undoes the square root. I put that in parentheses to capture it because I'm going to distribute that negative. This one already had both terms, so just plus x squared, all underneath my new denominator. Now I want to distribute that negative to both things inside. So negative 16 and a positive x squared. Sorry, I can't read that. So negative, and so it's 16 minus 16, so that's 0. So that numerator becomes 2x squared, all over 2 times the square root of 16 minus x squared. The 2's cancel, and I am now done. Thank you.